Hi everyone, good evening. So today we are going to talk about application load balancer. In the previous sessions we discussed about traffic manager. Now we'll talk about application load balancer. As usual, just we go through the Azure document, what they says about application load balancer, and then we'll see the practical how we can configure this Azure load balancer. So what is Azure load balancer? Load balancing refers to evenly distributing load incoming network traffic across a group of backend resources or servers. Azure load balancer operates at layer 4 of the open systems interconnection OSI model. It's the single point of contact for clients. So load balancer distributes inbound flows that arrive at the load balancer's front end to backend pool instances. So these flows are according to configured load balancing rules and health proofs. See, very simple to understand. And in load balancer, you have two types of load balancers: public load balancer and private load balancer. Also, we can call it as external load balancer or internal load balancer. So why we need this load balancer? What is the purpose of this load balancer? Before that, we'll just discuss. In Azure, we have a basic load balancer and a standard load balancer. Same way in AWS also we have load balancers. So those are completed like AWS. For AWS also we have a load balancers. There we have a network load balancer and a application load balancer. I'm not sure how many of you completed AWS application load balancer. So here in Azure, we have application gateway. So same way here, whatever the network load balancer will do, here basic load balancer and standard load balancer will do. And here application load balancer, whatever it will do the work of application gateway. After finishing load balancer, Monday we'll talk about application gateway. So just this is for the information whoever completed AWS. For them, the comparison like this two is equal to this network load balancer and this is equal to application load balancer. First of all, what is the purpose of this load balancer? What is the requirement of it? So this load balancer, like for example, any application, if you take just a second, we take one server to run. If we are starting any e-commerce business, like we take any e-commerce online shopping business, we started it. So initially when you start that business, obviously very less servers are very less users are going to be there because it's not that much of famous. So by default inside this operating system will be there, and on top of that you run some applications to run your application. So what are the application you are going to run? Obviously it is having a backend some middleware, and then it is going to have a database. So this is minimum setup: one server, one database. Assume this is your starting point, but slowly your business is increasing. So when the business is increasing, so for this, what you have done, you install OS, application is running, and it is having a public IP because it needs to be accessed from the external world, right? Through internet. So directly you cannot do publicity with your public IP. Everyone, you cannot give public IP to go and log into my portal, e-commerce portal. So obviously what you are going to do, like we did yesterday, the DNS mapping. So in DNS, you are going to configure in public DNS, you are going to configure with this IP, some public IP, and then the domain name, whatever you have. Let's say if it is Myntra.com. So whoever trying to access Myntra.com, based on this, it will come and it will go to the route to the server because of this mapping, and whatever the content is inside this, they are going to access it. That is how it's going to happen. This is fine, but slowly the business is increasing. Lot of users are trying to access your site. Then what you need to do, you cannot increase the capacity of your server. Okay, vertically, even though if you increase, it will keep on become very big. So then what you need to do, you need to have multiple servers. Like then slowly you'll increase, add one more server with same image, same application is running inside this another machine, because initially traffic was less, slowly traffic is increasing. And you added two more servers because it became very popular. Now, when this became very popular, now you have, are you going to create one more public IP to this machine, one more public IP, and are you going to write one more mapping over here, like with the new public IP? You have only one domain. Here, this domain is mapped with this public IP. What about this public IPs? If you assign one more public IP to this machine, and here also if you have one more public IP, what are the applications running inside? If whoever is accessing from the internet, from the for them, initially they are accessing Myntra.com, it is routing to this public IP. Fine, it is going to this machine. Now two more servers has been added. So you are not going to create new website for this IP and another domain name, right? Instead of Myntra, some other name. Then you will have multiple websites. I don't want that. I have only one domain name. Backend, it should have the same content. So then the load balancer will come into the picture. So here, load balancer will play the key role. So whatever the IPs you have, all these IPs will be mapped to this load balancer. And even though if you have more servers, few more servers also, all servers, these are called as a backend for this load balancer. So all these IPs will be mapped to this load balancer, and load balancer will have one IP. So it is going to have one IP, front end IP, and this IP we are going to configure it inside the DNS. So this is not going to change. So in the DNS, what we will do here, what are the load balancer IP? We configure load balancer IP with the domain name, something like this. So you may have 4 servers, 40 servers for your application. So all will be mapped to this load balancer. So load balancer will take the request and it will route the traffic to each and every machine. So in round robin fashion, it is going to send traffic to each and every machine. That is the purpose of the load balancer. In every real-time application, obviously they should have the load balancer compulsory. Without that, it is not possible to run. If it is a single server, then it's okay. Everything will be in the same server. But in real time, obviously, see, any e-commerce business if you take, they will not run on a single server, right? Backend, they might have hundreds of servers depend upon the usage. If you take Facebook have hundreds of servers backend. Depend upon the usage, how many users are daily accessing, how much traffic is coming. Based on that, you'll have multiple servers in the backend inside this load balancer. So that is the purpose of load balancer. So now we'll see how to configure this load balancer. And before that, we need to understand this is called as an L4 and this is called as an L7. And here also same, this is called as an L4 and this is called as an L7. So what is this L4 and L7? So most of you are completed, I think, engineering. Those are not engineering background. If you are not aware, I'm not sure, like OSI model. Everyone might have heard, not everyone, mostly OSI model. What is this? We have multiple layers, application layer and presentation layer, and then session layer, transport layer, network layer, data link layer, physical layer. So these are the different layers in the OSI model. So this is called as an L7 and this is L6 and this is an L5. Transport layer is L4. So here this is L3 and this is L2 and this is L1. So here this application gateway. So we are talking about this one. Application gateway belongs to layer 7 and load balancer will come at this one, Azure Load Balancer. So what is this? What is the difference? So here difference is, this is Azure Load Balancer is a TCP. So the communication, whatever is going to happen, it is going to accept every type of communication. But whereas application gateway only works with the HTTP and HTTPS, which means only web servers. If any web servers want to configure, then only it is going to accept this application gateway. If it is not an web server, then it is not going to, you cannot configure application gateway. So in the communication, there are different ways of communications are available. All those communications will be accepted by this TCP IP. But application gateway will only accept web applications, HTTP and HTTPS, then only it is going to take the traffic. So that is a difference between application gateway and application load balancer. This is Azure managed. Will that be a single point of failure? See, it is Azure managed. While creating, you need to decide whether you want to create a zone redundant load balancer or non-zone redundant load balancer. If you create zone redundant load balancer, then obviously it is going to have high availability for load balancer also. It depends upon you. And traffic is between regions. Mostly we use Azure Load Balancer within region only. If it is for global, then obviously we have discussed we can use a traffic manager, or else we have one more option called front door. Any of them you can use for global. If within the region, you can use the load balancers. Again, you are asking same question. Yesterday itself we discussed, 2 days we discussed the traffic manager. Traffic manager is global. Whenever your applications are running on different regions, then you need to configure traffic manager. Also, yesterday we discussed about routing protocols, right? Routing methods, right? So routing methods is not available for the load balancer. Routing methods is only for the traffic manager. If users are coming across multiple regions, different places, then how you want to route the traffic to which region is based upon the traffic manager. So what are the routing methods you configure based upon your application usage. So here within the region, you have an application and people are accessing it. Let's say you are in India, Myntra mostly will be used in India, and you created a servers in India region and you are running application. So this way, most of the scenarios, 70% kind of scenarios will be the same. So load balancer will be used in most of the projects. Okay, so okay. So this is about the Azure load balancer. Understood? So now we'll try to create this Azure load balancer, and as usual, so what we are going to do, we cannot create this backend application servers or maybe this one. And also we were talking about a public LB and a private LB, which means now here, if multiple application web servers are there, then obviously you are going to have a multiple application middleware servers also will be available. So obviously these also will be multiple. So what we are going to do here, So we are going to configure a load balancer here, and this is an internal load balancer. Now all this traffic is going to come to this load balancer, and this is going to route the traffic to this particular middleware servers, application servers. So this is internal, means what? This no need to connect from the internet. Internally within the private range, these machines are connecting to load balancer, and load balancer is transferring load to equally to these machines. So this is called internal load balancer, and this is external. So most of the scenarios, some applications no need external load balancer. So you can go with the internal load balancer. So that is the difference between this one. So here you might see, if you see here, this is public load balancer. So from traffic is coming from the internet for the TCP port 80, and internal load balancer backend. This is running with some another application servers like middleware, JBoss or WebSphere, WebLogic, Glassfish. This kind of middleware applications are running. Then this load balancer will route the traffic to these machines. So now I created a document here, Azure Load Balancer. I think and one more thing we need to discuss. As I mentioned, basic load balancer and standard load balancer. Basic is a free, standard is a chargeable. So few things you are not going to get in the basic because it's a free. Standard load balancer will going to get all the features. So that is a difference. And basic load balancer, as I said, if it is free, few things it will not support. We can see the difference also. Difference between basic load. So you see here, protocol both are like TCP UDP, it will support IP based, NIC based backend type. And here only thing is health props. HTTPS is going to support by the standard, and HTTPS is not going to support by this one. So your standard load balancer will support HTTPS, HTTP, TCP, but application gateway will not support TCP. It will support only HTTP and HTTPS purely for the web application. And this standard load balancer is for all the communications. So you can check the comparison here. Most of the things are not available for the basic. Availability zones option is not available, and HA ports is also not available, and multiple front ends only inbound. These are the differences for basic and standard. So we are going to select standard only, so we get all the features anyhow, because still we are using the free tier, so we can go with the standard load balancer. And I created a document. So here, so this is the one. So I'm going to create an RG, and inside this RG, we are going to create a VNet, and inside this VNet, we'll create subnet as usual. The same will create multiple subnets. So single VNet, multiple subnets, and inside this, I'm going to create an NSG, and this NSG we are allowing every port, or we can go with the 80 only. That's up to you. And this is the availability set we are creating. Always remember, previously when we were practicing other topics, I never created availability set, but this time I'm creating availability set. Why? Because load balancer expects your machines should be created under the availability set. Why? Because what is the purpose of this load balancer? Equally distribute load across all these machines. So if you don't create this in the availability set, then load balancer is not going to accept to add these machines or map these machines to the load balancer. Why? Because high availability. There is no high availability. If all the machines are created in the same rack or all the machines are created in the same server, then if something goes wrong, then load balancer cannot do anything. So that's the reason it recommends either create these machines inside the with the availability set options, or else these machines should be configured as an auto scaling option. Instead of individual virtual machines, these machines should be pack of an auto scaling concept. So if it is auto scaling is configured for all these servers, what happens? If something goes wrong with the server, then immediately auto scaling will create one more server. If this goes wrong, auto scaling will create one more server. So obviously your servers are highly available. So load balancer will accept either auto scaling of your VMs, or maybe if it is not auto scaled, then better to create those normal individual VMs under the availability set feature, so that in the data center it will be highly available. Understood? So next class, after finishing the application gateway, we are going to talk about how to create our servers, or maybe how to create web applications, or what are the servers under the virtual machine scale set, which is called nothing but in AWS auto scaling, VMSS. We called it as virtual machine scale set. So that's why I'm creating availability set, and then we are going to create VMs. I'm not going to create 3 VMs, because as you know, only 3 public IPs it will allow. So 2 I'm going to use it for VM, and 1 IP we can use it for the load balancer. So now let's go and actually I have 2 documents. I'm not sure which one I should follow. I'm not sure what is the difference between these 2. Okay, let's go with this one. So I'll go and create it. Instead of here, not portal. Okay, so here I'm going to create one resource group first. So resource group is created, and one VNet. So this is an IP range for this VNet, and then one subnet is enough, because I'm going to create only 2 VMs. So already here one created at the time of creating VNet, and this is enough, because for 2 VMs 2 are enough. So one more subnet I'm going to create. Because to create load balancer, we should have this setup, this machines, and we need to, same like yesterday, we need to install Nginx inside this one. And I just changed the index.html file so that we can identify load balancer is equally trafficking the load, distributing the load to each individual machine or not. We'll see that. And I'm creating one NSG also. Why we are creating NSG? Because instead of having its own 3 multiple NSGs, we'll create one and we'll attach this NSG at the time of creating the specific VM. So that's the reason we are creating. Otherwise, we can ignore it. Each VM will create its own NSG automatically. And again, you go there and allow port 80. That is also work. creating NSG here, and here allowing all the ports, but as per like this requirement, port 80 is enough to allow. Unrecognized arguments. East to US. Where is East to US? Okay. We no need to provide here region name. Why? Because already NSG is created and we are creating a rule. So here we did not give any option before East US. So that's why it is giving an error. Okay, rule is also created. Now creating availability set. If you see Azure are in this region, in this location, I'm creating this one, fault domain 3, platform update domain, this one 5. And this I'm attaching during the creation of VMs. If you see here, -hyphen availability set, what are the name I provided? So creating availability set now. We don't need to give 3 and 5 because we are creating only 2 servers now, right? So 2 and 2 is enough here. No need of 3 and no need of 5 here. Fault domain 2 and this update domain 2 is enough. Once it is done, here creating public IP. Why we need to create public IP separately? Static public IP. So we can create a static public IP, and that static public IP we can attach it to this one. Why? Because if you don't create static public IP, your VMs will create public IP, but it will be dynamic public IP. So when it creates dynamic public IP, then when we add that IP to the load balancer, here we are adding IP to the load balancer. Yesterday we added DNS name of your machine, but here we are adding public IP. So if it is a dynamic, then if you reboot your machine, then what happens? It is going to get a new IP. So when it gets a new IP, then it doesn't have the new IP. So that's why I created like static IPs. So we'll see. We'll create 2. As of now, I removed everything from yesterday's lab. So it should give me 2 IPs now. 2 IPs has been created. I provided some name to it. So Azure public IP, Azure pub IP2, and the same names I've provided for VMs here, Azure pub IP, Azure pub IP2. So now let me create a VMs. And this is a second machine I'm going to create. And here we attached NSG and also public IP also we're attaching. In the first line, can't it possible to create a VM without public IP? as we are configuring load balancer with public IP, so do we need public IP on VMs as well? Yes, we need public IP for VMs also. Difference between static IP and private IP. Static IP. See, you need to understand public IP and private IP. Static IP, dynamic IP. These two are like combination. These two are like combination. Static IP means manually dedicated IP you are assigning, whether it can be private IP or public IP, doesn't matter. Static means fixed IP you are assigning to a machine. Dynamic IP means dynamically it's changing the IP. Okay, it can be public IP or private IP. Here you need to understand what is public IP. Public IP means through internet you can able to access it. Private IP means within the network only you can able to access it. That is the difference. So here you are asking what is static IP, private IP difference. But these two are like, you can ask difference. What is the difference between public IP and private IP? And static IP, dynamic IP means dynamically you can assign, means randomly it will change the IP address, whether it can be public or private, doesn't matter. Static IP means whether it's a private or public, you are taking one IP and assigning to it. Fix until you go manual and change it, it will be fixed. That is a difference. I hope you understand. Rajesh Chopra. Private IP is always not static. How you are assigning it? See, right now you are creating VMs. Are you going and assigning a private IP to your VM? No, right? DSCP is assigning private IP to your virtual machines. You are not going and assigning. You are just selecting the subnet, and inside that subnet you are creating a VM. From the subnet it is assigning an IP to your VM. Understood? See, you are confusing. Static IP is the way you are using your IPs. So you are asking static IP is chargeable. Here you need to understand IPs are private IP and public IP. That's it. Static means how you are using that IP. The procedure is called as a static. Okay, VMs also created. Now I'll go to the home page here. Virtual machines. Only one virtual machine. What about the second virtual machine? VM create Linux. I think I did a mistake here. I think I did not execute second command. I think so. Okay, let me execute this one. Second VM, paste. Okay, second VM is getting created. What I'll do, I'll go and install Nginx in this machine. So I'm going to take this IP address, public IP address, and log into this machine. So I'm connecting to this machine now by using the credentials. Accept. So connected to one of the machine. Now I'm going to install Nginx. As this is a Linux machine, I'm going to install Nginx to practice, assuming some application is running inside this web application. So this is an Ubuntu. So we need to use apt update first. And then what I'm going to do, I'm going to execute another command called apt install Nginx. Simultaneously, two commands will get executed. Yeah, can private IP by dynamic means? Yes, your virtual machines, whatever the IPs you are getting, you are not going to each and every VM and assigning the IP, right? If you are going to the VM and you are assigning the IP manually, then it's called as a static. But when you are creating a VM, automatically private IP is also getting assigned, which means Azure is assigning private IP to your machines dynamically by taking from the subnet. So Nginx is installed, etc init.d Nginx status. It is up and running. And in the meantime, I'll go and see whether one more machine is also created. Yeah, one more machine is also created. So go to this machine, take the public IP and connect to it. SSH. Cloud Freak. So connected, login as a root and same apt update, absent apt install Nginx. Two commands in single go. DSCP handles assigning private IP also. Yeah, DSCP, Azure DSCP is automatically assigning private IPs to each and every VM. Okay. Here also it is installed. Same application should be there. If you have 10 machines, 10 should be the same, because only load balancer when distributing should not mismatch the data. Everything should be the same. So then only front end user can able to access it properly. Both are having same. But what we are going to do for our sake, like when load balancer is trying to access, how we know which server is getting the traffic? So for that purpose, same like yesterday, I'm going to this path /var/www HTML. Under this path, I'm going to see index Nginx. Open this file and go down here. Change this and welcome to server 1. This is the name I'm providing. And now I will restart the service, because what are the changes we do, it should take effect. So for that purpose, we should restart the service. Done. Restart is completed. And now here also in Linux 2 server, cd var www html, same file vi index, and open this file. Server 2, this is the name I'm providing. Understood? Now etc init.d nginx restart. So this is how I'm restarting it. Whether it's working or not, we need to test it by taking the public IP. You just go and try here. See, this is server 2, and here I'll go to the VM1, and here I'll take the IP of VM1, and then here I'll try to access. This is server 1. Successfully we are able to access. Basically it should contain the same data, but our testing purpose I modified this information. Now both are running. Now these two needs to be added to the load balancer. Now main thing comes. Our environment is ready. Now let's configure load balancer for this application so that your load will be distributed equally among all these two servers, whatever the traffic is coming from the internet. So now here in the search bar, go to the load balancers here. Now you can see load. We discussed traffic manager, and already I told you, like a traffic manager, if it is a global, then go to front door or traffic manager, anything will work. So load balancer is for within the regions. Now I'm going to create load balancer here. Create load balancer. So here resource group Azure RG1, because all the resources will be in the same RG, and name test load balancer region East US, and this is an SKU. So SKU basic standard, we are not configuring gateway as of now. So if you want free, for example, if you're not using a free trial and if you're using pay as you go, then you can go and configure with the basic only. But as of now, whoever are in the free trial, they have money is also available in their credit limit, then they can go with the standard. It's up to you. Both are same functionality wise, few changes are there. Apart from that, almost 70 to 80% same. And we are not configuring gateway. We'll see gateway in the later maybe Monday session. Okay, so same region, because my servers also created in the East US, and my load balancer also should be in the same region. And type already discussed. Public means what? External load balancer, which can be accessible through the internet. Internal means what? Within your private network. If this is your network, complete network, so internally here it will be accessible, not from the external world. So obviously we are using public, we want to access it through the external, and tier regional only, don't recommend for global. So can't we use systems ETL status nginx? Yeah, we can use it, but for me it's like habituated. I work on Docker containers, Kubernetes, right? So in Docker we don't have systems ETL, all these commands. For that I habituated to use etc init.d. That's why I'm using. You can use systems ETL also. So now next step is front-end IP configuration. So here, if you see, the basic information is provided. These many informations we need to provide. The first is front-end IP configuration. So front-end IP means for load balancer, we need an IP, that is front-end. So here add front-end IP configuration, name test LB public IP, something like this. I'm giving test load balancer public IP, and we are using IP version 4. So selected IP version 4, not version 6. And IP type is also IP address only. And public IP address here, if you see, can be associated with load balancer, cannot be associated with load balancer. These two are already assigned to the virtual machines. That's why we cannot assign this IP to the load balancer. It should have its own. So here we are going to create a new and name LB pub IP, something like this. And here if you see availability zone, someone was asking like load balancer is a zone redundant. So here you are going to select zone redundant. You want how many availability zones you are going to select. So backend also it is going to create in all the availability zones. Understood? So that's why you can select. If you don't want only one, you can select. Then there is a less high availability. If that load balancer is having any problem, this one, then the complete traffic will be blocked here itself if the load balancer is down. So in the real world, we'll select 2 or 3 based upon our requirement for high availability. So as of now, I'm selecting no zone. You can select multiple zones. Based on that, the charge will be also same way. If you are selecting zone redundant or multiple availability zones, the charge is also high. So I'm selecting no zone. And if you see assignment static, load balancer IP should be static, because static means fixed IP. So that will be because we are going to configure in the DNS. If it is a dynamic, then IP keep on changes after some time. Then in the load balancer, we are providing that IP, right? So that's how. So it should be like static only. So, okay. So gateway, we are not using gateway. So this is a front end IP, add. This is done. And next is backend pools. Next, we don't have any backend pools. Here select backend pools. Backend pool name, Linux web servers. This is the name I'm providing. Virtual network, where are these? Like in how many VNets it is available? It might be in different VNets also, and they might be having peering. So you can select multiple VNets. So wherever your VMs are available, as of now, we created single VNet and all these there in the single VNet. It may be if it is different VNet, that is also will be visible here. But as of now, these all servers are in a single VNet, and this is a VNet. And the backend pool configuration, NIC only, because to the VMs it is going to connect to the NIC. And now here we are going to add the IP configurations. IP configurations associated with to your virtual machines. So add. Here you can see your 2 VMs, and this is the information. Select, add. So these are the machines has been added. Okay. So here in the backend pool, we selected this as an, just I will remove it. Okay. Remove. Okay. Cancel. So here if I click on add backend pool, Linux web servers, this is a name and this is a VNet. If I select here, you can only add resources IP address in the virtual network. This configuration is associated with the IP address and will apply to any resources which is assigned. So if it is not a virtual machine, if some other resources, then it contains IP address, then you can provide the IP addresses here and the resource name. So your VMs, then you should select this NIC. Okay. So this way you can select it. And here what it is mentioned, IP configurations associated to virtual machines and virtual machine scale sets. Basically, in real time, we configure virtual machine scale set, and then we'll come to load balancer and we'll select virtual machine scale set over here. Why? Because what is virtual machine scale set? Virtual machine scale set means auto scaling of your VMs. So here, these are like individual virtual machines. So these individual virtual machines, if something goes wrong to this machine, then only 2 machines will be available. Then how it is going to take the load? So these two will become very busy. Performance wise, this is also will get impacted. If this is also gets down due to any issue, then only single server will be there. So in real time, you should have auto scaling to your virtual machines. Whenever if this machine goes wrong, it should create one more machine and it should intimate to the load balancer that it created one more machine. So this is possible only with the virtual machine scale set. So we create virtual machine scale set, and that virtual machine scale set, we add it here as a backend. But as of now, we did not completed virtual machine scale set concept. That's why we are creating individual virtual machines. Virtual machine scale set is also a virtual machines inside that, but it is wrapped up with the auto scaling feature, so that automatically whatever the numbers you define, then it will go up to that number. You mentioned max 6, minimum 2 means minimum 2 servers will be there. Whenever there is a huge load, CPU or whatever you configure, then it will go up to 6 based on your max value. And that package you will add it back end of the load balancer. That is what he mentioned. We don't have virtual machine scale set now. We have only virtual machines now. Add, attach the IP. There is no option for availability set. There is no option for availability set. Here we don't get it at the time of creating VM itself. See, when you are creating individual VM, obviously it doesn't have any high availability. So what load balancer is expecting, you are not creating virtual machine skill set. You are creating individual VMs. So at least make sure that while creating these VMs, backend, it should be highly available, at least in the data center level also. Understood? So it should be created in different racks and servers, so that if data center goes wrong, means that particular rack goes wrong or particular server goes wrong, still when you are creating 2 or 3 machines, the other servers are still available. That is minimum it is expecting from an individual virtual machines. And when we are going to the concept of virtual machine scale set, obviously you are going to select availability zones during the virtual machine scale set, and if anything goes wrong to the availability zone, or if anything goes wrong to the server, it is immediately creating one more server. So these are two options: virtual machine scale set. So virtual machine scale set doesn't have any availability. So minimum it is expecting mandatory to create them inside fault domain and update domain that we created at the time of creating those VMs itself. We created it, they achieved. If you don't create your VMs with fault domain and update domain, then your VMs here, when we come here at the time of adding, load balancer will not accept those VMs. It will tell minimum requirement is not fulfilled. Okay, so now select these VMs and add, save it. So backend pool has been added. Like you can create multiple backend pools. So this is one backend pool, another backend pool also you can add multiple servers. Altogether they will be into the load balancer. That is also possible. Understood? And next, inbound rules. So this is inbound rule. Here you need to create one inbound rule. Add a load balancing rule. So what is this rule? You created front end IP. You created back end pool, but there is no mapping between these two. So in this rule, you are going to map these two. So create a load balancing rule here now. Test LB rule, give some names. IP version 4, and front end IP address, whatever we created, this one, and backend pool, whatever we created, this Linux web servers, select this one. And obviously this is the TCP protocol, and port. Here we are whatever the applications right now, Nginx is running on what? If I see here, go to the Linux machines, netstat-ntlp, if you type, your Nginx is running on which port? By default is 80 port. So here you need to give 80 port, backend port. Backend means whatever which is running inside the server. And this port, when you try to access with the load balancer IP, some load balancer IP is there, 10.20, something like this. Here, do we want to use some other port number like 3000? You don't want to give 80. You want to give some 3000 or 3300. Then you should give here mapping. You don't want to expose your original port. In the load balancer, you want to give some other port, then this will work. So internally it is 80 is running, but externally it will take this port. That is how it will work. But I want to give 80 only here. Health probe, no health probes. So health probe is compulsory. We need to create it. Click on create new, and here health probe name LB health. What is this health probe? Your load balancer will keep on monitor your machines. That is the reason it will know that this machine is up and running or not. If no health probe is there, then as a round robin fashion, it will send traffic to here, here, and here. In 3 ways it will send. If this machine is down, load balancer will not know whether this machine is down or not. The third request will go to here also. When it sends to here, what happens? The third person, whoever is trying to access, for him it will get timeout or some XYZ error, 403 error, 404 error, because first one person when is accessing, it will go here. Second person request will go here. Third person request will go here. He will not get the response. Even load balancer don't know this is down. Again, same way, fourth person success, fifth person request is success, sixth person request is again failure. So like this, lot of failures will come. So to avoid this, load balancer should monitor this health status of these machines. Then only if this health status is down, then load balancer will stop sending traffic to this machine and it will send only to these machines. So that's the reason it is expecting health probe. So how you want to test it? You can test it in both way. TCP, if you select TCP, then it will check port 80 is listening stating or not. It will do kind of ping status, or it will send some API call to that particular port, whether it's up and running or not. It's like get call. Okay, so whether it's working fine or not, it will check. Or else if it is an HTTP, you need to configure the path of your website here so that it will check by accessing that website. So this is how it will do the validation. And how frequently? 5 seconds. For every 5 seconds, it will go and check. You want to change, you can change the interval also. For every 5 seconds, it will go and change. So you can change if you want. Default protocol is TCP. You can change it to HTTP also, TCP also. And okay, health, okay, LB health. This is health prop. And session persistence. So what is the session persistence? As of now, none is there. Client type is there. Client type and protocol is there. Session persistence means now we are talking about like multiple servers are there here, and we have a load balancer, and user is trying to access from here, and the request went to here to this server backend. And he, for example, we are discussing, let's say it's a Mintra, and he did some shopping and he purchased it and he logged out. So next time, whenever he tries to log in, if you are enabling this session persistence as a client IP, then whenever the same user means comes with the same IP, session is going to establish to the same server again. So when you are selecting client IP means what? This user, whenever is trying to access, then again it will send it to the same server based upon the IP. So that like that, whatever the users are trying regularly, they are visiting, it is going to send to the same servers. Understood? So next time, whenever log out and again they log in, then it will send it to the same server. Session, we call multiple names are there. Session infinity, session persistence. Sometimes we may need it, sometimes we don't need it. You might be thinking like, why, in what scenarios we need this? See, sometimes what happens, this may improve performance also. Why? Because every time load balancer, no need to validate the user, because we have already his existing information. He is also having cache, and server is also having cache, that here is a known user already logged in. So it will not verify every time when the user tries to connect. So when it's not verifying, what happens? The performance will increase, right? So performance will increase. Same like many users who were trying to access, regular users, whenever they're trying to access, then it is not going to verify based upon this cache. The traffic will be cleared easily. But there is another problem is also there. It's not man, if the session persistent is not enabled, calmly network this load balancer will traffic will be sent equally to each and every machine. But in this scenario, it cannot send equally. Some server may be fully busy, maybe some server is little bit less busy. That way also it happens, because most of the sessions might be going to one server, some sessions are going to the second server. So we don't know. So equally it cannot distribute the load at that time. Again, that will be also one kind of problem. So that's the reason we don't prefer the session persistence option should be enabled. So TCP reset, it's like a whenever a user logs in and he cannot able to log out, okay, so some reset is going to happen. So that we won't want to configure as of now. Floating IP, expose traditional load balancing IP address mapping scheme for ease. The VM instance IP enabling floating IP changes the address mapping to the front end IP. So whatever the IP which we configure for the load balancer, it will keep on change. So that is also we don't want it. So now create it, and an inbound natural forwards incoming traffic sent to the selected IP address and port combination to a specific virtual machine. So we don't want to configure NAT rules as of now here. For example, if you configure virtual machine scale set, at that time you cannot log into each individual virtual machine. Then we can configure this NAT rule, and with that rule we can able to log into that machines. If you see here, incoming traffic sent to selected IP addresses and port combination. Incoming means your internal traffic sent to selected IP address and port means backend, whatever these virtual machines are there, right? Backend virtual machines. If you want to send any internal traffic to these machines, then you can configure this NAT rule. So next is outbound rule. We don't want to create any outbound rule as of now. Tags and review and create. Create. Now with this load balancer IP, if I try to access, I should get these web pages, both server 1 and server 2. It is getting created. Kiran Babu Ganesh on using Azure Bash CLI where we can get Azure image. See, Azure is having lot of commands, right? Like how we are creating virtual machines. You can list out the items also, whatever Azure is providing. So list out the images, whatever Azure is providing. From that, just filter Linux images and copy the image names from there. That's it. The CLI, everything is possible. With AZ command, list out the images. It will throw all the images and then filter from that only to get the Linux images. You will get the image names over there. From there, you need to copy it. So resource is created. And if you see here, front-end IP configuration, this is a front-end IP configuration. Copy this one and try to access. See, I can able to access it. Because of this cache, it shows the same one. New incognito mode. You guys, I will ping in the chat. You just try this IP address to access. So it should give server 1 and server 2 also. Please let me know whoever tried to access it. Anyone got? I got both the servers. Good. Server 1. Yeah. So equally it is distributing the load. Whoever is accessing because of this cache, it's keep on getting for me the same. So 1, 2. So server is getting that response. This is how the traffic will be routed. Now only thing is left is we don't want IP address, right? We want our own domain name, mintra.com, like whatever the website you want to launch, that name I want. I don't want this IP. Same like yesterday. Whatever we have done. So go to the GoDaddy, like I have a website inside the GoDaddy and create here DNS zones. And let's go and create. We have more 15 minutes of time. So I'll quickly go and create DNS zones. So whoever did not join yesterday, okay. So now what we are going to do, what is the purpose? We cannot promote our IP address to everyone, right? To go and access our site. We want our own domain name now. Some website name, www.somexyz.com, what are the domain name? So we need to purchase inside the any GoDaddy or bigrock.in. So here I have a domain in the GoDaddy, that is init6tech.com. But GoDaddy is mapped my domain name in their DNS servers. So what happens if someone is trying to access init6tech.com, it will route to DNS servers, public DNS servers of GoDaddy. then this public DNS doesn't have any information or any kind of records to my website. So user who are trying to access from the internet, they will get errors. So for that purpose, what we are doing in the DNS zones in Azure, we are going to create a DNS zone, and those DNS servers I am going to update inside the GoDaddy, and I'll remove DNS servers of GoDaddy and update DNS servers of Azure. And then I'll come to the DNS of here Azure. I'll write a rule, means record load balancer IP and my domain name. Same like yesterday. So now DNS zones, go to DNS zone, create. As I mentioned yesterday also, whatever the domain name you are purchasing, with the same name you need to create this name, init6tech.com. This is the name. Resource group name is Azure RG1. Review and create. Create it. Deployment is done. Go to resources. So with this name init6tech.com, I created a DNS zone, and these are the 4 name servers it is provided. In this, I need to create a record with the load balancer and this domain name, like mapping load balancer IP and domain name. But before that, my website is in the GoDaddy. So there I need to change the DNS servers. So I log in there, sign in. Provide the credentials. You can also buy any domain name for just 100 to 200 rupees. Buy the domain name. And now I'll go to the my products. So here, this is my domain, and here also this is my domain, and you can see DNS settings of my domain. Go here and scroll down. You can see the name servers. These are the name servers which I created yesterday for traffic manager. I think same they are provided now. NS137, NS137 Azure -DNS, same names. Okay, I no need to change, because yesterday also they provided same DNS names. Today also they provided same DNS names. Generally, whoever logged in for the first time, here in the name servers tab, you will see GoDaddy DNS servers. So you need to change them. Click on change, and whatever this under the DNS zone, what are the name servers are available, copy these name servers and put it here. Yesterday for traffic manager, I configured this one. Whoever not attended yesterday, for them I'm telling, like, these are the name servers updated yesterday itself. Okay, so again I know to do it. So one final set is record set. So in the record set, I'm going to give www, and here yesterday we selected CNAME, canonical name, because traffic manager is having what? Domain name, galaxy.trafficmanager.net. That's why I selected CNAME. But now load balancer is having IP address. So I need to select alias record to IP version 4. And alias record set, yes. And alias type is obviously Azure resource. And what is that Azure resource? Here, This one LB, if you see here, this is the one. Select it and OK. So now once it is done, then when I type to execute www.init6tech.com, it should able to access the web page. Record is created, www.init6tech.com. See, I can able to access it. You can also able to try it. This is a path, and this is an HTTP, so not secure. You can also able to get server 1, server 2. Yeah, for me it's getting server 2 because of this cache. So this way we can configure in our real world also. If it is an internal load balancer, then internal domains will work. No need to have internet to access it. Internally, when you go to your office in your private network, some domains will work like an internal domains. One second, just be online. I'll be there in 1 minute. This is how it will work, the load balancer. So in the meantime, let me clear any. HTTP and health probe, anytime you can use. You can use either HTTP or TCP also. Until unless if this is a web server, then you can use HTTP. If this is not a web server, then you should use TCP for communication purpose, whether it's reaching or not. It's always not the web applications only, right? So there will be different APIs will be there, different communication is required. So at that time, TCP only will help you. How to drain the instances in maintenance activity. How to drain the instances means maintenance activity. Whenever you do maintenance activity from application level, there will be a scripts will be there that will put your application into the maintenance mode, so that that request will not come to that server. It will go to another server. Then you can do whatever the activity you want on that specific server. LB is also should be part of a VNet. It's not an external resource. It should be part of your VNet when you are creating LB. Okay, I think all of the questions I answered last. Sorry, I did not created that one. Today I was busy. Uh, During weekend, I'll create it. In the Monday's class, I will share the links. Okay. From morning onwards, I was busy with work. I couldn't able to create it. Tomorrow I'll create it and Monday I will share it. Okay, guys. Yeah, for TCP, it will send kind of like a get call also will send to check whether that port is up and running or not, port 80. If port is in not in listen state, then it is going to be declared as it is not working. How to add more machines to load balance if traffic increases? See, first of all, as I mentioned, backend pool, whatever we added, we created as an individual virtual machines. But it should not be individual virtual machines. It should be created as a virtual machine scale set. So virtual machine scale set, if you create, what happens? Automatically, your servers will scale up. Whenever there is a high load on this server, then immediately in whichever availability zone this machine was created, in the same availability zone, it will create one more machine. If this machine is having high load, it will create one more server. So this way it will keep on increase. Whatever the maximum value you mentioned, up to that value, it will keep on increase. We no need to go and manually add the servers to the load balancer, but still you can able to add it. I'm just telling like that is not the correct way. If you want to really manually add the servers, then go to the load balancer. Whatever the options we have seen right here, left side, these all are like backend pool, health probes. Same here, you go to the backend pool, again click on add and add more servers manually if you want to add it. But correct procedure is your auto scaling should do that. And again, whenever the load is normal, the servers will get deleted automatically. Again, it will come to minimum range, minimum 2 or 3, whatever you define the value, minimum value and maximum value. No need of any manual intervention. If you add more server manually, will that change the scale set value? No. If you are adding manually means what? That machine is not belongs to virtual machine scale set. Then it is separate VM. So it will be like two types. One is VM scale set machines are running. Another one normal virtual machines which you manually added. They are running. So they will be available until you go and remove it. And virtual machine scale set value be the same because virtual machine scale set is kind of a package. And you are adding separately one more server to the backend pool. That is separate. If you add in the backend pool manually virtual machine scale set minimum value will not change. Minimum or maximum value will not change. Both are different. Troubleshoot part on every service, it is not possible because you need to create a scenario, you need to troubleshoot means that is not possible to discuss in the trainings especially. Okay guys, so we'll meet on Monday. Thank you. Thanks everyone. I don't take any one-on-one classes. One-on-one means only one person to teach one person. That way I don't take any classes. Whether it's for Galaxy or for my individual training, I'll take based on the batches only. Like that way I will take the classes. Thank you. Thanks everyone. Have a nice weekend.